So we're going to talk about pivot rows and columns of a matrix. So I have this exercise. So suppose the augmented matrix for a linear system has been reduced by row operations to the given row echelon form. So we're going to identify the pivot rows and columns, and then we're going to solve. Okay, so to do this, so first of all, just what are these pivots? So a pivot position is where the leading one in a matrix occurs. So your pivot rows and columns are just going to be literally the rows and columns where this is happening. So when you have a row echelon matrix like we have here, it's actually pretty obvious how to figure these out. So you can pause if you want to read the examples, but I'm just going to jump into them. Okay, so this is already in row echelon form. So it's going to be nice and easy to figure out the first part of this question. So the leading ones are going to be where those ones on the diagonal or on the pseudo diagonal occur. So really it's like the first one in every row if applicable. So this one, and this one. These would be known as my pivot positions, and therefore this column, the third column, and the fourth column, those are my pivot columns. And then since this is where these would be the rows, these would be the pivot rows. These three rows, this is just the three that we have. Those would be our pivot rows. Okay, so to solve this, the other thing that's kind of important is to know the difference between your leading ones and your free variables. So in this case, so again, it's that first one really in the row, that's going to be your leading one. So my free variables, I can easily figure those out. Okay, so first of all, before I state what my free variables are, let's just remind ourselves how to label this matrix. So this column is going to represent my x1s, the next one represents my x2s, x3, x4, x5, and then this is the equal to column. So these represent the coefficients of an equation with these variables. Okay, so anytime you have a leading one, that will not be a free variable. So any column that does not have a leading one will be the free variable. Therefore, this x2 I know right away is my free variable, as is this x5. Because this column, and this column all have leading ones. Okay, so now let's do this. So the next thing that you're going to want to do is you're going to want to write out what each one of these equations are. And I think it's actually, I'm just going to start from the top. So this is going to be x1 plus 3x2 plus x3 plus 2x5 equals 5. The next one's going to be, let's see, I'll just write them all together, I guess. x3 plus x4 plus 2x5 equals 4. And then we have x4 plus x5 equals 2. Okay, so now, just so that I don't get confused, I think it's helpful. So some books do this and some books don't, I've realized. So some books do not declare what the free variables are. The book that I'm using in my class does. And I actually like declaring what the free variables are because then I don't get confused. So I'm going to let my x2 be an s, and I'm going to let my x5 be a t. So that when I look through these equations, what I can do is I can actually now replace. So my x2 was an s, so that was my only x2, and then my x5 we said was a t, so I'm just going to replace all of those. So the reason why I do like that system is it makes it a little bit easier for me to figure out what I'm solving for now. So to keep going with this, let's make a little more space. Okay, so I think the nice thing about plugging in your free variables is then you remember that they are free variables. Okay, so now I'm going to really go from the bottom up. So I need to solve for x4. So to solve for, let's see, x4 is just going to become 2 minus t, so that one's done. So next I'm going to move up here, so I can replace now my x4 with this equation here. So I'm going to have x3 plus 2 minus t plus 2t equals 4. So that's going to be x3 plus 2 plus t equals 4, and then I can subtract everything off to get x3 will now equal just 2 minus t. So I subtracted the 2 from the 4 and the t from the 4. Okay, cool. And so now I need to use this, right, for this last equation. And I think I'll try to, let's see, I'll make a little space here. Okay, so I just moved my x3 up so I can see it. So now for x1, well, I know what x3 is. It's this here. So I'm going to have now my x1 plus 3. I'm like so nervous about making s's look really clear. I should probably choose a different free variable for other videos. So 3s plus 2 minus t plus 2t equals 5. So now I have x1 plus 3s plus t plus 2 equals 5. So my x1 then is going to equal 3 minus 2s minus t. Okay, cool. And so now I have all of my solutions. So just to summarize this. So here's my x4. Here's my x3. Here's my x1. And then remember, my x2 was an s and my x5 was a t. So there's your solution set. Okay, so I am always a fan that if you are trying to understand this, I always say math is not a spectator sport. So if you're trying to understand this, I'd strongly recommend that you at least pause the video and try this one totally on your own to see if you can get it. And then if you're stuck, you can check your answer against mine. Okay, so once again, so we have to start with just the pivot rows and columns. So that part's simple because I just look for the leading ones. So I go row by row and I just look for that first one. So here are my pivot positions. And so then this, and this are my pivot rows. And this, and this are my pivot columns. Okay, so that's part one of this. And then I am going to go ahead and just label this again so that I don't forget what each variable is. And so now we can get the party started, right? So I'm just going to write out what each one of these lines means. So I'm going to have x1 plus x2 plus 3x3 plus 2x5 equals 7. And then I'm going to have x2 plus 2x4 plus 3x5 equals 1. And then I have that x5 equals 1. Now, before I go any farther with this, the other thing that I want to note, so if this, and this are my three leading ones, or my leading variables, then these two columns here are going to be free variables. So I am just going to note that, and I'm going to label them. So for my free variables, so my x3, I'll call my x3 r, and then my x4, I'll make it a t. Okay, so now when I think through this, my x3s I'm just going to replace with an r, and my x4 I will replace with a t. So I can also see now that I didn't have to make a lot of substitutions. And then the other thing that I want to point out, so this x5 can be replaced here. Okay, so let's make some space again. And now, so my x5 is just an actual numerical value. So now I'm going to use that here. So this is going to turn into, so let's write out this line now. So this line will turn into this x2 plus 2t plus, now instead of being 3x5, this is going to be 3 times 1. So this will just be 3 equals 1. So now I can easily solve this for x2. So this will become, so I'll subtract off the 2t and the 3. So this becomes negative 2 minus 2t. Cool. And then I need to solve this. And I do have a solution for x2, boom. So I'm going to replace that. So this is going to become x1 minus 2 minus 2t plus 3r. And then remember my x5 I can replace here. So this will be 2 times 1, so this will just be 2, so this equals 7. And now, once again, so I can collect my like terms, so you'll actually notice here that the 2's actually cancel out entirely. So that means that my x1 will just be 7 plus 2t minus 3r. So then once again, just to highlight what my three solutions are. So my x1 is a 5, my x2 is negative 2 minus 2t, my x1 is here, and then we said that the x3 was free and the x4 was free. Okay, and so there is your crash course on pivot points and free variables and all that good stuff. So if you found this video helpful, I'd love it if you hit the like button, and otherwise I will talk to you guys in another video.